Let's talk about square root of a number. To begin with, let's write the squares of natural numbers and try to represent them geometrically in terms of areas of squares. Now we know that 1 times 1 represents, so this is 1 square, and so 2 taken 2 times, so that is represented by 2 squared, and 3 taken 3 times is going to give you, this is 9, so that is 3 squared, and this is 4 times 4, which is 4 squared, is represented as 16, and this is 5 times 5. Okay, now looking at this geometrical representation, so if you look at the numbers here, so you know this is 1 times 1, which is 1, and 2 taken 2 times, that will give you 4, and 3 times 3 is 9, and 4 times 4 is 16, and 5 times 5 is going to be 25. Now just look at this number here. So if you look at this number, say 9, this is a product of two identical numbers. Geometrically, this represents a square of area 9 units square with side lengths of 3 units each. So you can see the side lengths of this square is 3 units each. Now, we say the square root of this number, say 9, is one of its identical factors. So that is 3. Suppose we have an area of 25 units square represented by a perfect square. A square root of a number, say 25, is one of its two identical factors. So the side length of this perfect square is going to be, so this is one side length and this is another side. So you can look at this as, so this side is going to be 5 units and this side is going to be 5 units. And this is represented as a symbol, say a square root. So these two sides, so this symbol here is actually called the radical symbol. So this is called a radical symbol. So initially it was represented as a single vertical line like this. Now this is called a radix. So this symbol was called a radix. Now this is a Latin term from which the word radical was derived. Now later, so they had a problem. Suppose I am giving you a number, you want to find out square root of 9. So this is much more easier. So this is 3. Suppose if I give you, you need to find out square root of 9 plus 7. Now there are two possibilities. One is, so you can just find out square root of 9. You can just write it like square root of 9 is 3 plus 7, so which will give you 10. Or it may also be, I would have asked you to calculate square root of 9 plus 7 together. So if it is 9 plus 7 together, then there should be square root of 16, which will give you 4. Now which of these is correct? So now the question arises, should I consider the horizontal bar as well? So now this horizontal bar will tell you, should I consider both the numbers together or not? Now this horizontal bar has a name, it's called the vinculum. So in mathematics, the horizontal bar, it tells you it is drawn over a group of terms indicating they are to be operated as a single entity. And that is how we got the symbol square root. We call this as a radical symbol, which is read as, this is called square root. Now every positive number has two square roots that are additive inverses of each other. Now just take this 25. So this area of this square here is 25 units square. Now this number 25 has two square roots that are additive inverses of each other. So one is, it could be either plus 5 or minus 5 because it is plus 5 times plus 5, that is going to give you 25. Or even if you multiply the two identical negative numbers, so that is the product of two identical negative numbers, so minus 5 times minus 5, that is also 25. So which means if you say you want to find out the square root of 25, it could be plus 5 or it could be minus 5. But geometrically, minus 5 times minus 5 doesn't make any sense. So if you are asked to calculate square root, then it means that geometrically we say the positive square root of a number is called the principal square root. So that is plus 5. So the positive square root is actually called the principal square root. Okay, now the principal square root is simply represented as, say, root 25. Now you can write this as just plus 5. If they are asking you to calculate the negative square root of this number, then it is represented as minus root 25, which is minus 5. So if you look at this symbol here, this normally represents the principal square root, which is only the positive value of the square root. Let's find the square root of a given number. Now there are several methods to find out. The first method is prime factorization. Okay, the first number here is 144. Now for 144, if you do the prime factorization, so you know the normal procedure of doing prime factorization, so it is 144. So you just divide this number, so I'll divide it by 2, so which will give me 72. Again divide this by 2, so that gives you 36. Again divide this by 2, so which will give you 18. And again dividing this by 2 is going to give you 9, and divide this by 3, which will give you 3. So divide this by 3, which will give you 1. Now, so you have the numbers here. So you need to write these numbers. In terms of two identical pairs. Now say for example, so I have a number which is represented as 2 times 2 times 2 times 2 times 3 times 3, which is 144. Now is it possible for you to represent this number in terms of two identical factors? Now say for example, if I want to represent this in terms of two identical factors, which will give me 144, because if I want to find out whether 144 is a perfect square, now a perfect square is nothing but a factor multiplied by itself. So these two has to be identical factors. So I have two 3's here, so I'll put one 3 here and the other 3 there. Okay, now out of these four 2's here, so I'll put 2 2's here and the remaining 2's here. So I have two identical factors. Now these factors clearly tell me this is 4 times 3, which is 12 times 12 is 144, so which is a perfect square. Okay, so now the square root of 144 is 12. So if you want to find the square root of 144, that is going to give you 12. Now let's take another example. Now I will give you a number which is, say, 216. Now let's see whether this is a perfect square or not. Now, so if you do the prime factorization here, so 216, you start dividing it. So when you divide it by 2, so you get 108, and again you divide this by 2, so you end up getting 54. So again dividing it by 2, so you end up getting 27. So divide this by 3, so you get 9. Again you are going to divide this by 3, and then finally 3. Now if you look at these numbers here, so you have this is 2 times 2 times 2 times 3 times 3 times 3. This gives you 216. Now is it possible for you to write this in terms of two identical factors? Now say for example you cannot write it simply like 2 times 2 times 2 and 3 times 3 times 3 here. They are not identical. So I want two identical factors here. So what happens here is I have 3 3's and 3 2's. So which means I can just simply write it as 2 into 3 is one factor, 2 into 3. But I have one more pair which gives you 2 into 3. So this gives you 216. So this clearly tells you this is not a square number, but instead 216 is a cube number. So I have 3 identical factors here. So which means each factor is 6. So it is 6 times 6 times 6 is 216. So this is actually 6 cube, which is 216. So 216 is not a perfect square. Now in finding square root of a number, so we have another method. So this is based on estimation. Now just look at this. So when you want to find the square root of a number, and if the number is represented as n, now so if you have even number of digits inside the square root, then the square root will have n by 2 number of digits. Say for example, if I take a number which is say square root of 64. Now 64 has 2 digits. So which means that it has even number of digits. So if I have even number of digits, then the square root of this number is going to be, this capital N stands for number of digits inside the square root. So which means this square root of this number is going to be 2 by 2 number of digits, which is 1 digit. Okay, if the square root has odd number of digits, say for example, if I have a root of 169. Now I have 3 digits here. So if it has odd number of digits, then the square root will have n plus 1 by 2 number of digits. Okay, let's check this. So now root 169 is 13, which has 2 digits. So since it has 3 digits here, it is going to be 3 plus 1, 4 by 2, which is 2. So which is a 2-digit number. The square root of this number is a 2-digit. So here, if the number has only 1 or 2 digit, then the square root of that number will have only 1 digit. If a number has 3 or 4 digit, then the square root of this number will have 2 digit. Let's take some examples. So let's first take square roots of perfect squares. Now let me take a number. Say this is square root of 1444. So now we know that if the number has 4 digits, then the square root of this number is going to be a 2-digit number. Okay, so this number is going to have 2 digits. Now, all you need to do is look at the units digit of this number. So if it ends with a 4, now we will just take squares of these numbers. Now you can see there is a pattern here. If the number ends in a 9, so that means that the square root of that number should end with, that is the units place of that particular number will be either a 3 or a 7. So if it ends with 4, then the units digit has to be either a 2 or 8. So which means if you look at this number here, it ends with 4. So if it ends with 4, then the units digit here, it has to be either a 2 or a 8. So I need to find the tens digit here. Now in order to find the tens digit, now you can just make an estimate. So this is 1444. Now what will be 30 squared? So you know this is easy to calculate since it ends with 0. So 30 squared is nothing but 900. Now what is 40 squared? Now 40 squared is 1600. Now you can see that this number lies between these two. Now take the in-between value. So just square that number. So say for example 35 squared. Now what is 35 squared? 35 squared, numbers ending with 5 is much more easier to square. So if you have 35 squared, all you need to do is the last two digits is going to be 25. So you just take this 5 square and the last two digits is 25. And the digits before this is nothing but product of this first number 3 into the next consecutive number. So that is 3 times 4, which is 12. So 1225 is the square of 35. Now you can see that this number 1444 is in between these two values. So which means the number which you are looking for, the tens place is of 30s, and you need to decide whether it is 32 or 38. And now it is easy for me to find out that this number 1444 lies in between 35 and 40 squared. So that is square root of this is going to be between 35 and 40, so which is nothing but 38. So this is how I conclude the square root of this particular number. Now let's take another number. Say for example, square root of 529. Now square root of 529, so I can just calculate 20 squared, which is 400, and then I can calculate 30 squared, which is 900, and I know this number 529 lies between these two. So which means since it is a 3-digit number, I will have the square root of this number is going to be in 2 digits. And it is going to be in 20s. The tens place is going to be in 20s. Now since it ends with a 9, so since the number is ending with 9, so you can see that the square root of this number, so if the number ends with a 9, the square root of this number will have a units place either 3 or 7. Now if it is going to be 3 or 7, now you can see that take a number in between 20 and 30 and then square it, which is 25 squared. And 25 squared, as I told you, so this is 5 squared, which is 25, and the number before this. So take this number 2, multiply the next consecutive term to it. So that is 2 times 3, which gives you 6. So 625 is 25 squared. Now you can see that this number 529 lies between 400 and 625. So the number here has to be 23. So root of 529 is 23. Now the third method here is called the difference method. I normally don't suggest this method, but it's always good to know that there is one more method to find out the square root of a given number. Now we can just look at the squares of these natural numbers. So 1 squared is 1, 2 squared is 4, 3 squared is 9, 4 squared is 16, 5 squared is 25. So it goes on like this. Now suppose if I take the differences of all these numbers, so you can see that the difference between 1 squared and 2 squared, so this difference is 3, and the next difference between 4 and 9, this is 5, and then the next difference here is 7, the next difference is 9, the next difference is going to be 11. So it goes on like that. Now if you look at all the differences here, this is nothing but an odd number sequence. So it just follows an odd number sequence. It's like say 1, 3, 5, 7, because 0 squared will be 0 and the difference is going to be 1. So it is always like it's 1, 3, 5, 7, 9, 11, the next difference is going to be 13. Okay, so this gives me an idea. So if I calculate, say for example I'm going to have, let me start with a very simple number, say just take 16. You know this value 16 is nothing but root of 16 is 4, but we'll just start with this simple idea. Since we know the differences here, so if I want to find out the square root of 16, so you just start with 16, and you know you need to start subtracting backwards if you take the differences here. But I don't know whether I should start with 7 or 5 or 3, so instead I'll do the reverse process, just subtract 1. Just keep subtracting odd numbers alone. So when you subtract 1, you end up getting 15. And the second term you need to subtract is 3. You subtract only the odd number sequence. So if you subtract 3 from this, so you get 12. And the third term, you subtract 5. So that is the next term in the odd number sequence, the consecutive odd numbers is 1, 3, 5. So if you subtract 5 from 12, you end up getting 7. And the next consecutive term of the odd numbers is 7. So you end up getting 0. So if you look at the number of terms you have subtracted, so this is the first term, this is the second term, this is the third term, and this is the fourth term. So this number 16 is nothing but this fourth term squared will give you 16. So therefore root 16 is 4. So this is another method, but you can do this for smaller numbers. Suppose I have another value, say let me take some number like say 21, and I want to find out the square root of 21. So let me first find out whether this is a perfect square. So if I just do this subtraction process, if I just subtract 1, which is my first term in the odd number sequence, so I am going to get this as 20. The second term is 3, so that will give me 17. And the third term is 5, so which will give me 12. And the fourth term I need to subtract is 7, which will give me 5. And the fifth term I'm going to subtract is 9, which will give me minus 4. So I'm not going to end up getting 0 here. So this is very clear. So therefore, this root 21 is not a perfect square. Now, how do you find out square root of a non-perfect square number? Now, this method is slightly simple, so it is easier to understand. So, say for example, I have a number root 170. So, 170 is a non-perfect square. So, how do you find out the square root of this number close to 2 decimal places? Now, the first step is to find the square root to the nearest integers. Now say if it is 170, then I know that the closest integer, which is a perfect square, is 169, and the next closest is 196. Now square root of 169 is 13, and square root of 196 is 14. So which means the square root 170 lies between, so square root 170 lies between these two values 13 and 14, and it is much closer to 13. So what I have to do is, so I know that square root of 170 is approximately 13. So in order to find the decimal places, I will divide, so that is my step 2. So step 2 here is to divide 170 by the estimated value, so that is 13. Okay, so if you divide this by 13, so you know it is 13 times 13 gives you 169, and you have a remainder of 1, so this is 0, so you cannot divide this, so therefore this is another 0 here, make it 100, and you know now it is 13 times 8 is 104, and 13 times 7 is going to give you 91. Okay, this is going to keep going like this. Now I have this 13.07 is my quotient. Now I have the divisor here. Now step 3 is to take an average of the divisor and the quotient. Now the average of these two values is going to be 13 plus 13.07 divided by 2, which is going to be 26.07 by 2, which will give you 13.035. Okay, so this is much closer, so therefore that is square root of 170 is approximately, this is only an approximated value, so this is 13.035. So why do you call this as an approximated value? Because if you just square this number 13.035 square, and what you get here is, this is actually 169.911, so which is not exactly 170. So that is why we say it is an approximated value, but it is much closer to 170. Hope this is clear.